Okay, now we're going to look at horizontal transformations. Okay, so we have the horizontal translation and horizontal stretch factor. This one is going to be a little bit different though. When we're looking at horizontal transformations, it doesn't appear to be as you'd expect. But once I explain it, hopefully it'll make sense. So with the vertical transformations, we had the letters outside of the function, a and d. Those are vertical transformations. We're multiplying the old y values by a and then adding d. The horizontal transformations are inside the function, so inside the bracket here. So horizontal stretch by a factor of 1 over b would have a b in front of it here. So it's a horizontal stretch by a factor of 1 over b, the opposite of what you expect. And then it's a horizontal translation, negative c, so the opposite of what you'd expect. Okay, and by doing this, we're looking at what happens to the x values when we fix the y values. So we're going to look at the quadratic again. Okay, so y equals f of x, which equals x squared. But because we're looking at the effects of what happens to x, we're going to rearrange this formula and solve for what x equals. And when you do that, you get x equals plus or minus the square root of y. Okay? Same function, but we just rearranged it to define what x is. And the same graph, but we're going to look at the table of values just a little bit different here, just for instructional purposes. Okay? So instead of xy, we're looking at yx, because we're going to leave the y values fixed as 0, 1, and 4. Now the reason I use 0, 1, and 4 is because they're the easy numbers to square root. So I could have used 0, 1, and 2, but then I would have had root 2 on the x coordinate, which would have been fine. Just easier to see when we do it this way. Okay? So 0, 1, and 4 for the y give me plus or 0, plus or minus 1, and plus or minus 2 for the x coordinates. Okay? So if we want to graph this one here, y equals f of x minus 2, well, that's just x minus 2 squared. And we know what that looks like from what we know about quadratics. That's shifted to the right 2. Okay, which often people will make mistakes and think that that should be shifted to the left 2, but because it's inside here, it's shifted to the right 2. And we're going to explain why. So what we're going to do here is we're going to solve for x in this one as well, so that we can see what the effect is on the x coordinates when we leave the y coordinates fixed. So by getting rid of the square here, we're going to have x minus 2 equals plus or minus the square root of y. Now we bring the 2 over, and we've got x equals plus or minus the square root of y plus 2. So you can see that the old x values used to be plus or minus root y. Now you're adding 2 to it. So the effect of having minus 2 inside the function notation here really means it's a plus 2 when you're defining what x is, because you have to bring it to the other side. When we were looking at the vertical transformations, we had a definition for y, so just adding something to the end gave a direct effect. So putting the x minus 2 in here gives us the opposite direction effect for the translation. So when we look at the table of values, well, we've got the y coordinates are staying fixed, 0, 1, and 4. And we're taking the x coordinates, 0, plus or minus 1, plus or minus 2, and you're adding 2 to each one of those. And it becomes 2, 1, and 3, 0, and 4. And when we plot these, we've got 0, 2 is the vertex. Okay. 1 and 1 and 1 and 3 are those points. 4 and 0, 4 and 4, 4 and 0, 4 and 4 are those points. So it's shifted to the right 2. Now what happens when we put the number inside as 2x? Well, that's just 2x squared. Okay? Sorry, there's an can see it now. So that's just 2x squared. And the effect of this, well, we've never really graphed this before. We usually just square the 2 and it becomes 4x squared, and we have a vertical stretch of 4. But what happens when we look at it this way? Okay, well, when we rearrange it for x, we get x equals plus or minus 1/2 root y. Okay, because you get rid of the squared by square rooting. You're going to put the plus or minus in, so you get 2x equals that, and you get rid of the 2, so you divide both sides by 2, and you get plus or minus 1/2 root y. So the effect of having this 2 here is actually a horizontal stretch of 1/2, which means takes all the old x values and multiply it by 1/2. If I had a 1/2 in here, then I'd bring the 2 to the other side and become 2 over here. So 1/2 in here would have a horizontal stretch of a factor of 2. So it's the reciprocal of whatever this number is. And you can see this in the table of values. Okay, so we take the old y values and the fixed y values and the old x values, 0, 1, and 2, from our table here, 0, 1, and 2, multiply them by plus or minus 1/2. Okay, and we get half the coordinates. And we end up with a horizontal stretch of a factor of 1/2. So it used to go a distance of -2 to 2, which is a horizontal distance of 4. Now it goes from -1 to 1, which is a horizontal distance of 2. So half the width, horizontally stretched by 1/2. Okay, so now let's take a look at a couple more examples here. So if we take a look at this one, these two, sorry, there are interpretations of this that people have, and they might make mistakes, so I need to go over these. So y equals f of 2, x minus 2. From our notation here, we know that this is a horizontal stretch of 1/2 and a horizontal translation of 2 to the right, because it's a minus 2. Many would say the same about this one. They would say that there's no difference. But notice these brackets in here. We don't have the brackets in here. So let's see which ones works out to that. Okay, so what we're going to do here is we're going to put them into their explicit notation here. So we're squaring what's in the brackets. Now we've got to isolate for x. So what I'm going to do is square root both sides, the plus or minus. Okay, so this one becomes 2 times x minus 2 equals plus or minus root y. And this, same sort of idea. And then I'm going to keep isolating the x here, so I'm going to divide both sides by 2 in this one. But this one, I'm going to add 2 to the other side. Okay. So x minus 2 equals plus or minus 1/2 root y. 2x equals plus or minus root y plus 2. Okay, because the minus 2 becomes the other side. And then I'm going to add 2 to the other side for this one to get rid of the x, or the minus 2 on this side. And I can see that this, the old x coordinates, which was plus or minus root y, are multiplied by 1/2 and then added 2. So they've been horizontally stretched by 1/2 and then translated to the right 2. So this has the proper effect. Now this one, when I divide both sides by 2, well, I work that in and I get this. X equals plus or minus 1/2 root y, which is still a horizontal stretch of 1/2, so that 2 still means a horizontal stretch of 1/2. But it's only been translated to the right by 1. So this minus 2 here did not mean translate to the right 2. It was 1. So in order to get the proper effect, you need to make sure that the inside of this is factored, and we want it in this form. Okay, so y equals f of 2 bracket x minus 1. And now you've got a horizontal stretch of 1/2 and a horizontal translation of 1 to the right, okay, which is what this is supposed to give. Okay? Now, if you look at this, this is going to be a horizontal stretch factor of 2, and the negative means a horizontal flip, so a reflection in the y-axis. So a horizontal flip. In a quadratic, that doesn't do anything because it's symmetrical about the y-axis. And then this means a horizontal translation left 3, okay, the opposite of that sign. Right? Now, for a pointwise formula, like we looked at for the vertical stuff, well, if you go from f of x to y equals f of bx plus c, well, what we did before with the vertical stuff was we did this here. We took the old y values, multiplied them by a, and added d. That was pretty self-explanatory. But this one, we're not taking the old x values and multiplying them by b. We're multiplying them by 1 over b. And then we're not adding c, we're subtracting c. So this is the pointwise formula you get for horizontal transformations. Okay? And now we can put them both together, and we'd have something like this. So for f of x goes from f of x to y equals a, so the whole thing together, a f of b x plus c plus d, we do the y, the vertical transformations, as ay plus d, and then the horizontal ones as 1 over b minus c. Okay? So for example, if you wanted to go from f of x, some function, to this transformation, then you'd have this formula. Negative 3x minus 1. We don't change the negatives here, we just take the reciprocal of the number. And then 2y minus 4 for the y coordinates. So if you had some key points, you could do this. Okay? So some other examples of this formula are right here. So from f of x from here to here, you would have this as the formula. Okay, so 1/2 x plus 4, and the y's are taken directly. Here's another one. You can pause and try it. Okay. And here's the answer for that. You need to factor out the 1/2. Okay? So if you multiplied this negative 1/2 in, you would get this. Okay? And then you could do the formula. You can't do this formula until you've factored the inside. And then this one, same idea. Again, you have to factor this. So you've got that. Okay, so how do you factor that? Well, what do you multiply by 2/3 to get 5? Well, it would be 15 over 2. Here's a way of looking at that. Okay, so 2/3 a equals 5, so you can just divide it, and there's your formula. Okay, and now if you want to go from root x, which is this function, to this one here, well, first you'd have to do this. Okay, factor out the inside, but I could have given it to you in either of these forms. I could have said graph these functions, and you would have had to realize that the root function for this, or the parent function, is square root of x, and you would have had to put it into function notation and then get the pointwise formula. Okay, so there's your pointwise formula. There's key points for this one. Use those key points, and you get this graph. Okay, so there's the formula doing what we did. Plug in the key points from here. For any function, the key points, and then you plot those. And does it have the right effect? Well, it's been vertically stretched by a factor of 2. This went from 0 to 2. This goes from -2 to 2. Vertically flipped, yes. Horizontally stretched by 3. Used to go from 0 to 4. Now it goes from 3 to -9, which is -12. That works. Okay? And so on. And that's it for the combination and horizontal transformations.